Hello there, Khaled Al-Malamani here. Today we'll talk about the basics of the Arduino language and how to get started in coding using the Arduino language. Let's get started. So as you can see here, this is the sketch for the Arduino. When you first open Arduino, as long as you have not used Arduino before, this is what you should see. Having noted that, if you have not installed and set up your Arduino, then you should probably check the video previous to that just so you can install it and get it ready. In this case here, let's get started with writing the code. First thing we should always note is one of the most important things in coding is comments. Comments allows you to understand what you're doing. In other words, that if you check your code maybe a week later, a few days later, and you implemented a few things that you don't remember, or you whether it's important or whether it's specific to a certain task, the comment allow you to do is pretty much remember it. And another thing important about comments is if anybody else reads your code, whether it's your team members, your TAs, in whatever setting you're coding this for, then it is important to have comments to be so they can understand what you do. The first type of comment we should include is a comment at the very beginning explaining what the code is for. So in this case here, we'll include a /* comment. The /* comment is the minute you set it up. So if you when you /* and then you press enter, it's Arduino sets up all of this for you. So all you have to do now is just start writing. In this case here, we're just going to do Arduino basics tutorial. So, and this will be a version 1. Now, the idea of the version 1 is that when you're coding, you should build in versions. In other words, if you have a functional version and this is what you're trying to do, keep it that way. Because when you start implementing new feature, your whole code could break. Okay? If it does break, you would be happier if you have another code that works that you could go back to. Otherwise, you have to restart everything or start debugging the one that you just did, and you won't be able to finish it in time. It's extremely stressful. That's why coders always use this type of versions. For team member purposes, you can also use GitHub, which also allows you to be able to work the same way. Each time you push anything, it is as if you're creating a new version of your code, which is important. I will talk about GitHub in other videos to come. But for now, this is how you should also do it on your computer. So we have our Arduino Basics tutorial, and then we can just include a line here where we talk basically what this program will entail. And we can just say that the following will include features of the Arduino language for training purposes. Okay? And then we could also include a section called required components. So the required components is if somebody is reading your code and trying to build or upload your code into their device, what you're including here is the various components or the various things you're going to use for that is required by this code. In this case here, all we're going to need is your Arduino. In this case, I'm using the Arduino Mega. So I might as well include that, but it will work with any Arduino device or any Arduino knockoff too that you are using, as this is only the basics. So I'm using the Arduino 2560. And then another line we could also include is the date that you have this. So we could say today is December 20, 2020. And we can also include the author, which me, Khaled Al-Malwani. In this case, you'll include your name. And that is basically what you can include up here. If you have components that requires connections to the Arduino, you could have a pinout section, which maybe, I don't know, maybe you have a speaker. So if we go here, for example, we could say, for example, the speaker is connected to speaker, and We could say it's connected to pin 3, for example, right? So we can include something like that. In this case, we don't have a pinout or we don't have any external peripherals or sensors. So we can just remove that section here and this is what we'll have. But this is the idea of the pinout that we have here. Now, after you have your comment here, what you should do right away is save. So either you can press the save button or Control S or Command S. So we can just click on save here and we can call this Arduino Basics Tutorial version 1. Now the idea of the name here, the name is actually quite important too. What you're trying to do is name it a name that you'll be able to understand if you come back to this a year later, a week later. The name should be, you don't have to open your code just to know what you're doing, right? So this is the name we're going to call it, and then we can save it. As you can see, it's saved properly because the name of the sketch changed from random values to Arduino Basics Tutorial V1. So we have that here, and then we can include, and then we can start talking about the actual language further. So in Arduino language, as you can see from the comments here, you have your setup code at the top here and your main code here. So in this case here, the setup code is the code that only runs once, okay? So the idea is this will only run one time, it will never occur again. And this is for setup purposes, which we'll talk about too in a few minutes. The void loop is something that runs repeatedly. That means when it starts running sequentially, of course, every line that you have in your void loop here, after it reaches the closing bracket, it will come back to the top and keep doing that forever. Okay, so the void loop does not stop. It just keeps on going forever and ever. And that is useful, or that is how the Arduino language was developed. And that is how you can build your various Arduino features. Now, let's say you only have stuff that only occur once. You're building a code that only requires to be done once. You don't want it to be done repeatedly, so you include it all in your setup. You still need a void loop. So for the Arduino language to work, you need these two functions. You can have as many functions as you want, but you always need the setup and loop function, because the Arduino compiler always looks for these two functions. If you don't have them, the code will not work. So this is what we have so far. So we can go into our setup here. The next thing we can talk about is one of the most important features of the Arduino, and that is the serial communication. So the serial communication starts with, of course, serial. The serial is a class, or it's a function. It's just a feature that you can start by saying future, and you want to initialize it. To initialize it, you use begin. And then inside the begin brackets, we want to include the baud rate. The baud rate, simply, you can just think of it as the speed of the serial communication. So the number itself may not make sense. It's just, as the name implies, it's just the baud rate. But what should make sense to you is 9600 is the default number. So most microcontrollers will, most if not all Arduino microcontrollers work with the 9600. Some microcontrollers would work with less and some work with more, but 9600 is the default setting that you have on here. When we talk also about Bluetooth communication, baud rate is important, and also when we talk about how to use the MPU 6050 in another video, that is also very important to understand the baud rate, or in other words, just to be able to use a proper baud rate that will not affect the code. If you do not use either of these two, then you can just keep it as the default setting here. And then it is important that we always include comments. Now, as you can see, the beginning comment here was a /* comment. In these types of comments here, what we actually do is a double slash. So that is the normal comment. There is a slight difference of color. One is slightly lighter than the other. And so we can just write here that this is initializing serial communication. And this is what the serial.begin does. I can even specify more and say that it specifies it as at 9600 baud rate. Okay. So this is what we have so far. Now, an important thing to always do is to verify your code. When you verify your code, even when you're uploading it as well, it saves and then it verifies. If you're uploading your code, it saves, it verifies, or in other words, it compiles, and then it uploads. So in this case here, it is not, I do not want to upload it yet, so I can just press on verify. And as you can see here, it is compiling your sketch. And if everything is correct, it just goes done compiling at the bottom here. So this is what we have in this case here. Now, another important thing to note is the serial print command. So the serial print command, after you initialize your serial begin, you want your microcontroller to send a few commands to your computer or a few through serial communication. Just to have a stronger understanding of what serial is, serial just means any connection, usually USB, to your from the microcontroller, which in this case I'm using the illegal car kit, and to your computer using via the USB. So we just plug it in. If you have a Windows machine, it produces a small noise as it tells you it's plugged in. And if you do have your board plugged in, some lights will light up on your microcontroller. Anyways, so this is a serial communication, and then we tell here to print a certain statement. In this case here, I want to print hello world. Notice in hello world here, there is no space between the quotation mark and the exclamation mark, and there's no space between the capital H and the quotation mark, and there is no space between hello and world. So if I start this code here, let me just add a comment, which is a good practice to have a comment on every line of your code. So in this case here, what we're printing is printing hello world through serial communication. Okay. In this case here, if I upload the code, how you should think of serial communication. The serial communication is starting the serial communication on the microcontroller. The serial print tells what the serial print does is in many cases, a lot of programmers think that it's saying the computer is printing to the serial monitor, which I'll show you what it is in a second. But what it's actually happening is the microcontroller is the one printing to the serial controller, not the computer. This is important to keep in mind for your debugging purposes, because everything that happens in your microcontroller, even the serial communication, is from your microcontroller, not your computer. So when you upload your code, it's all from the microcontroller. The serial monitor is at the top right corner here. It's the magnifying glass icon. We can just select it. As you can see, the serial monitor for this one, for the IDE, just auto scrolls and it just extends to the right, especially that we didn't have a line feature. If we look closely by stopping the auto scroll, you'll see that there is no space anywhere as exactly we have written in our code here. There's no space anywhere between the quotation marks, so there shouldn't be any space in our print function. So the serial print does not include any spaces of its own. You have to tell it exactly what to do. Okay? So this is what we have for the hello world here. Now for coding, for training purposes, let me just add a space here and then upload this code. If we upload the code here and we reopen the serial monitor, which is actually still open, we can see if we auto scroll, you can see here there is no spaces. But if we auto scroll and reach to the part where the code is actually updated, you'll see that they add a space. So in other words, the serial monitor does not clear the output every time you upload code. If I actually go side by side, if I actually reduce the screen here so you can see the monitor, what it does is it grays out a bit. And then after it uploads the code, it restarts the code, it restarts the serial monitor as it is. If you want to clear the output, which is a good practice to do, and at the bottom here, there's 3 lines. You want to clear the output, and it will just, everything that you had at the beginning will clear. Another way to clear your output is just close it and open it again. And you just clear the output. This is where the baud rate I was mentioning. As you can see here, you have multiple baud rates. The Arduino Mega and the Arduino Uno can go from 300 up to 115,200. And then some microcontrollers can go to even higher. But in this case here, 9600 is the default. As I mentioned, it will work for most microcontrollers. Yep, so that is the serial print command. Now, the good thing about the monitor or the serial monitor in Arduino is when you upload code, it stops the serial monitor, it stops the serial communication. But if you use any other serial communication, let's say TeraTerm, for example, which is a popular one, and let's say I close this one here because I don't need it, and I start the serial communication for the port that I'm currently using, it will do exactly as it is. The only difference is that the TeraTerm does not have a side scroll, so it pretty much wraps around the code. So at the end of this line, it goes to the other line. But if I try and upload code from the Arduino to the board here, it will give me an error. As you can see the error here, if I just expand my screen, it says the selected port such timeout does not exist or your board is not connected. So what actually happened here, even though all your connection is correct, is that the TeraTerm, because it's using the current serial communication, there is no, as I mentioned at the beginning, the serial communication is required for uploading code as well. So it's currently being used by TeraTerm, right? So it cannot, there's no serial communication anymore. What you need to do is disconnect it. Of course, in TeraTerm, there's two ways. Either you can go disconnect, close it, go through disconnected. And if we try and re-upload our code, it will upload. So if you are using any other serial communication, which is quite common, then what you need to do is then you have to make sure that you close or disconnect your serial communication if you're uploading any new code. Otherwise, you can just use the serial monitor on the IDE. So this is about the serial communication. And then now let's talk more about global variables. So global variables are, as the name implies, global. So they are variables that will work in all the functions. Void setup is a function and void loop is a function. So that means that any global variable that I assign can be used in either setup or loop. And I will show that right now. So let's say I go here and I declare, or we can just include a section here, declaring global variables. Now, as you can see here, we have a comment on the line by itself. And in these two lines here, we have a comment on the same line of the code. This is just a convention. If you're going to declare various variables or you're going to declare a section, for example, you want to start initializing in the setup function here, you want to initialize the servo motor, for example. Okay, the servo motor requires a few things to have, or let's say you're initializing more servo motors, more than one. And you can just have a function at the top here. You can just include a subsection comment at the top here. And just underneath it, you can just include all the inputs that you have. So this is how you would do, this is how this comment works. As I mentioned, it's just a convention. Convention or just a set of rules just to make it easier for your coders of the same language to be able to use the various inputs, or to be able to either use your code or even just be able to read it. So this is what we have here. Now, when we declare global variables, we can assign a variable, let's say int, to global counter. You should not include spaces, so counter. A convention again is to use camel case, and the first letter is non-capitalized. That is a Java convention, can be used in Arduino. Now I could assign it, or in this case, we'll be initializing it at the very beginning. Okay, but this is not again following property. What you should use is you declare your global variables at the top here, and then you initialize it, or you assign a value for it in the setup function. Yeah. So this is what we have here, and this will be assigning global variables. And then, as I mentioned, because it's a global variable, it can be used in any function. So if we go back to our void loop here, I can go global counter plus plus. Now the plus plus function is an incrementation by 1, so I can include that and say that this is incrementing global counter by 1. And in this case here, this is assigning global counter to 0. Now, global counter plus plus is the same thing as if you say global counter plus equal 1, which is also the same thing as you say global counter is equal to global counter plus 1. And that's why you need to actually assign a value first, because you have 0, you need a value for this one. So in this case, it will be 0 plus 1, and that gets stored to global counter. So everything that, if you have an equal sign, anything that you have on the right side has to occur first. So in this, and then that will be assigned to anything on the left side. So global counter plus 1 is 0 plus 1 and store it in 1. And these three here are the same thing. Now you could also increment by any value, right? You can increment it by 2. And in this case, global counter will just increase by 2. You could also subtract it. Remember, integer variables are anything that is 0, 1, 2, 3, 4, 5, or 0, negative 1, negative 2, negative 3, 4, 5, and so on. So anything that is a positive or negative integer on either side of the 0. So it's a positive or negative. So I can do that. I can also divide by 2. So in this case, we'll just keep dividing by 2. Now 0 divided by 2 is just 0. So in this case, won't really make a difference. And you can also times, which is just the star. So division is the slash, and star, which is shift 8, is multiplication. So this is everything that we need for incrementation purposes. And that would work for either global or local variables, which I will talk about local variables in a second, but all incrementation work the same way. So this is how it works. So in this case, we incremented the global variable by 1. And then let's say I want to print it. Now in this case here, I'm going to use the println function. What the println function does is it prints, or in other words, it prints the whatever you have inside the bracket, which I'll include in a second here. And then it adds a new line, right? So in this case here, we can go print the global counter. Notice that I'm not using quotation marks. Notice that I'm not using quotation marks, because quotation marks will print exactly what is inside the quotation mark. In this case, I just want to include the counter, and the counter is a variable, and I don't want to include the name. I want to include the actual variable. So I can just include my semicolon here. And actually, for coding purposes, I'm going to forget my semicolon by accident. And then I'm just going to add a comment here, the print value, or you can even say print value of global counter to serial. Okay, so in this case here, I forgot my semicolon. If I go upload here, it saves. As you can see, the symbol for the save disappear. And then it compiled, and when it compiled, it failed because it says here it's expecting a semicolon before the token. Notice how it doesn't see the comments. So when you have your comments, the compiler just ignores it. It doesn't see them at all. The comments are only for human purposes. So anybody reading your code. So in this case here, I just need to add my quotation mark, and if I upload this, again, the symbol for the save disappears, so it's saved. It's compiling. Now there's no issues. It uploaded and it's done compiling. If I open the serial monitor here, as you can see, it prints the current value of the global counter, and it keeps adding by 1 for every loop iteration. And as you can see, the loop just keeps going forever. Okay, so this is what we have here. And then we can even add a small comment here for every iteration. Now, a good thing to have in your global variables is a comment that what it's going to be used for. Okay, so we can say that, because in this case here, that's also for your debugging purposes. Because if you do use your global variable in the wrong place, then this will make you notice it. So we can just say that here, variable will be used, or we don't have to say will be, just used to track the iteration of the void loop function. Okay, so this is what we have here so far. So that is what we can talk about the global variables, the serial command, and as well as the comments. Another important thing to note here is local variables. So local variables, again, as the name implies, are any variables that are only for the local. So in this case here, we can just say declaring, or we can initialize right away local variable. So this local variable that I'm going to initialize here will only be oops, sorry, that's a typo here, variables. Anyways, so if the local variable that we're going to have here is only going to be for this void setup. So just to show you here, we can go int, we can call it local counter, and we can say it's equal to 1. And if I try and go here and go local counter, and I try to increment it, it will give me an error because it is a local counter, right? It's only local to set up. So if we say that we're trying to increment the local counter for every loop iteration, and we try and upload our code here, saves, compiles, and then tries to compile it, and it will say that local variable is not declared in the scope. So the scope is anything that is between the squiggly brackets that you see here. That is what a scope is defined as, right? So if it tells you there is something is not declared in the scope, just see within your brackets here if the variable is included or not. That means that when we go into if and for loop statements, you do include your squiggly bracket as well, and that is a scope. So a local variable is local to a scope. So it can either be a local to a function such as void setup or void loop. It can be local to an if statement, a for loop. If you want anything that's going to be used in more than these, then you need a local, so you need a global variable. Okay, so global and local variables could get a slightly bit more complicated because you could have a local variable to a function that is global to various scopes in your function. So if you have an if statement and a for loop statement and a while loop statement, and you have a local variable to the function void loop, for example, all of these, the local variable to the void loop will be global to the functions, which I can show you in just a second here. So as you can see, this does not work. And then in this case here, let's just actually put it in here. Now let's just let's put this in a new line just for easier to see. And I don't want to print this anymore. So I can just go Control/ and it will just comment this right away. It's a good feature to know because I can select more than one and go control this as well. If I press it again, it just uncomments. So in this case here, we can just include our int local counter, and this here assigning the local counter to 0. So the local counter here is local to the void loop function. And I can declare an if statement. So an if statement is a statement that will only occur if what you have inside there has happened. So in this case here, I could actually do an if statement to a global counter. And I say that if global counter is equal to, I don't know, 5, then we can open our squiggly bracket and press enter. Now Arduino just closes it for you if you press enter. And then we can say if it's equal to 5, serial dot print ln, or actually what we could do is we can go local counter plus, so we increment it by 1. And then we can say serial dot print ln. If you did a mistake, especially in serial commands, it will not change color. So let's say I do a typo and go NL instead of LN. You can see the color did not change. So you can, those are visual ways you can know if you made a mistake or not. And then we can just go local counter and press that. So once again, let's not forget our comments. So incrementing local counter could say here that occurs for this statement occurs when global counter is equal to 5, incrementing local variable by 1, and this here then will be printing the current value of local counter. So first of all, just do a mental check of what is supposed to happen in here. So in this case, what we can see is that what we're trying to do is when the global counter is equal to 5, the local counter will increment by 1, and then we'll see it printed. So if we launch this, we should only see this occur once. Once again, you can see here that this is not saved. So if I upload, you can verify or save, these will all save it. So I'm uploading and compose the sketch. And then there is no issues, so it starts uploading. And if I open my serial monitor, you will see that there is one several times. Now, you might wonder why is that occurring, okay? So, because how we thought about this is we said that, okay, maybe the local counter should only occur once because the global counter will only equal to 5 once, right? So in this case here, that's when the serial command is important. And that is because we are running out of SRAM. So SRAM is the amount of memory storage that is available for us on the microcontroller. Now, when we printed the global counter, it's not showing the actual speed of how quick the void loop is. That is because every time we use the serial command, it has to wait. What the void loop does, it waits until the communication is completed. But the void loop is extremely quick. So if I actually pull this code again, just to verify it and show it. So what is happening is that the global counter is incrementing every void loop. Now it's overflowing, so that means that it actually reaches the negative side. And I can show that in a second here. So it actually reaches so it goes, even though it should be all positive, it overflows. So if you have a slight idea of how the bit number works, if there is the most significant bit is 1, which occurs after a bunch of iterations, after incrementing for so many times. If you increase it enough to the most significant is equal to 1, then the 1 at the end, if it's a signed integer, which it is because the int is a signed variable, and that means that it's a negative. I won't go into the details of how it works in bit, but that's what happens. So it increases past a certain value. After that certain value, it overflows. That means it becomes negative. And after it becomes negative, it becomes so big that there is enough space in it anymore in the RAM. So the whole computer or the whole microcontroller resets. That's the issue when you have a global counter. You should try and make sure that you don't increment it too much using the void loop. It's usually a better way is you increment it every certain thing. So you use an if statement and you increment the global counter every certain case, every certain such. It's a common mistake. It's not easy to catch. People do not see it right away, but it is a pretty common mistake. So the bunch of ones you see is it overflows, the microcontroller auto resets, and after it auto resets, it recompletes this. Now, just to show you that it does reach the negative, this is equal to -5. If I upload this here, and I launch it, as you can see, after uploading, it does repeat the 1 here. So this is important to notice here. So it does reach, it does overflow and goes to the negative, and then it repeats. So to avoid this here, we can just remove this increment that we have here. Or another thing that we could do is either use the local counter as the incrementation. There's multiple ways to work around this. but it really depends on what you're doing as your application. Now, something to mention, and that is your local counter here. It goes, it starts at 0. So as you can see, when we launch our code here, it doesn't matter that we have -5. You can see it never goes past 1, and that is because how a void loop works is it goes to the end here, and then it comes back to the top and increments global counter by 1, and then it restates the local counter equal to 0. So you have to keep that in mind. If you're working with local counters, if you assign it inside here, which I mean, that's the only way you should do it, you assign it inside the local counter. When this resets, it will reset. Now, if you there's ways to use the local counter. If you remember here, the local counter, this local counter here is global to the if statement, and it's also global to any statement you have another. So I could have another if statement. That means if I have another if statement here, I could, or maybe just an else to the if statement. And then that means I can say I can still use the local counter and say local counter is equal to 2, for example. And that means here I'm assigning local counter to 2. And so this is what we have here. So the local counter is equal to 2. That means that if the global counter is not equal to -5, then the local counter will be equal, then just set the local counter to be equal to 2. There's another if, and this here is important. The idea of using if and else statements, and also else if statements, which is just another statement. We keep saying maybe the global counter is equal to, I don't know, 6. And let's keep this at 5, even though we know it will overflow. We can just keep it for here, and then we could say is else if global counter is equal to 6. Now this is important because if I had this as 2 if statements, that means it will run this, it will check the if statement here, and it will check this if statement here. But if I have it as an else if statement, then what I'm doing is if this statement occurs, then it will skip the else if. If I have multiple else if statements, let's say else if global counter is equal to 7. Okay. Now what happens here? Let's say I have one here that is equal to 6, and let's say, or let's say here that we have equal to 6, bigger than or equal to 5, and equal to 6. In this case here, anything that you have inside your else if from line 36 to line 75 will never occur, because 6 is bigger than 5, right? It is equal or bigger than 5. That means when it reaches this statement here, any else if statement afterwards, or any else if or else statements afterwards will not be considered. It will just be ignored. That's the idea of the if and else if statements. They are extremely powerful. They are very important to use. But this is why this is important to have. Now, the else if statements here, as I mentioned, it's quite important to understand. But let's say I do want both this and this to work, then I can say an if statement here. Now notice that the else statement here is associated with the if above it. So if I want it, if your logic works and it's still, and you want to keep it here, you can keep it here. Maybe that's not what you meant by your logic, and you want to give it to the top. You have to make sure that the else aligns with whatever the if statement you want at the top is. It doesn't necessarily have to align physically. It just has to be right on top. So the if statement has to be on top. So this is the idea of the if statement. Now, if we remove this here, now we can talk about for loops. The for loops, as the name implies, it's a loop, right? So you can create a for loop inside of a void loop, which what this allows you to do is you can have another loop iteration inside the actual void loop. And that means that any local variable you have assigned here will stay here. Now, just to avoid the overflow and the global resetting, I will comment out the global counter. So we can go here, you can assign an int inside the first statement of the for loop, and we can even initialize it to be equal to 0. But you can also have it outside. So I can declare another variable here saying int I, but then you do have to assign it here. You can also assign it on the outside. You can also say this, and then you say the variable you're going to use is I. These are all true, but these are not proper convention. What you should use is this one here. So you assign the variable inside. That means that int here will be local to for loop. That means that if you use I in your another, let's say, while loop, which I could show in a second here, the I that you have in your for loop will not be the same as the I that you have in your loop here. Now, just for this purpose here, I'm going to show another thing here. So if I name this as global variable, and let's say I keep this increment here. And just for the sake of the question here, let's say I go like this. And I now have, notice how the global variable is actually local and is the same as the one here. Local variables always precedes global variable. That means if you have a local variable that is the same name as the global variable, then your local variable is the one that's going to be considered, not your global variable. So that means that if your global variable had a value of, let's say, 6, and your int global variable has assigned to 0, if I CO print this, you might guess that it will print out 0, not 6. Now, there seems to be an issue here. Oh, yes, because my for loop is not completed, so I just commented out for now. And then we can just upload it. It's completed. We can open the serial monitor, and you can see that it prints 0, not 6. This is important to keep in mind. It is also a common mistake. But then we can just keep going with all of this. And then here, let's say we have a local variable, and for int I is equal to such. And then in next statement of the for loop, we have our checking statement. So in this case here, we can say when I is smaller than or equal to 10, let's say. Now, in many cases, this is not the proper convention. The proper way to use this is to not have the equal sign and just increase your variable by 1. Because notice that 10 is smaller than 11, but 11 is not smaller than 11. So this will also only run 10 times. Why is this the proper convention to use? Because if you have an array, for example, an array of, let's say, 10 boxes, right? An array is just a variable that has a certain amount of that. So let's say I can declare an int array. So it has 10, an int array of 10. That means I have 10 instances of int inside that array. But you start counting from 0. So the final array box is just at array 9, right? So if you have I is smaller than that array size, and you just include that size, even though the size of the array is 10, the I will only stop at 9. Does that make sense? That's why this was developed that way, and that's why this is the proper convention. So, and then we have our incrementation. The incrementation is what you have at the end of the for loop. So at the end of the closing bracket here, you can imagine that there's an I++ right before the end of this for loop here. It is hidden in the compiler, but it's there, right? So this is how you can imagine it. So this is what we have so far. So this is a for loop. This will run 10 times because it starts at I equals to 0. It stops when I is equal to 11. And but it will not run when I is equal to 11. And how this works is, first of all, it checks this. It says it starts the initializer. It says I is equal to 0, and then it checks, is 0 smaller than 1? Is 0 smaller than 11? Yes, it is. So run whatever's inside here. After it's done, it goes back to the top here, and now it doesn't run the first statement. It just goes to the second statement and says now I is now equal to 1, right? It's 1 smaller than 11, and it is. So it runs whatever's inside, right? At the very end, I will be equal to 11 at some point. So, and then it checks, is 11 smaller than 11, which is not. And then, so that means it will not run anything inside here. Now, just for the purpose of showing you that this is true, we can just declare the I statement on the outside just so you can use it. Because remember that if it's local to the the scope, we cannot use it outside of the scope. So if we just use it inside here to put it out as a global variable to the for loop here, it's just local to the void loop. And we say, for example, what we want to do here, we can say the local counter plus, and I guess we could also go serial dot print. Now let's say you want to concatenate strings. Now even though this is built off processing, which you might know, you cannot use plus inside the print statement as you can do in processing. So what you have to do here is you go serial.print, and then let's say we want to add a statement, so local counter is, and then we add our quotation marks. I want to add a space just to make it look neat, and then we can go serial.print ln. Remember, it prints first, then it adds the new line, and then we can get say local counter, and then outside here we can say serial.print ln as well, or sorry, let's use I, and then say I is, and then we can go serial.print ln, serial.print ln, and then we want to print I. So what we did here is it's going to print 10 times the local counter, and then it's going to print I as 11. Let's double check this. And let's run it. So as you can see here, this is what we have. Now it is in a void loop. So that's why it keeps repeating. Remember, the void loop doesn't stop forever. But as you can see here, we're saying the local counter is 1, 2, 10. And then it also does the 11 here, which makes sense. And I want you to think about it for a sec. And then it says I is 11. And if you thought about it, it makes complete sense why local counter is 11, even though it's repeating 10 times, because notice that these are only 10 times. We start at 0, we do the local counter first, and then we print it, right? So that means that this will always be, will always start at 1. But let's say this is not how we want to start it. You can just change the location. You can just go like this. And that means it won't skip, it won't count to the last one. And if we upload this one here, and oops, let's auto scroll, and as you can see, it starts at 0 and then it increments, so you have 10. And as you can see, again, I is equal to 11, but the 11th count did not show, right? The 11th for loop iteration did not show. Now, as a proper convention, you have to remember to add your comments. For the sake of time here, I won't add them. Now, we can remove this I statement here, and follow the proper convention again, and keep int in here. And now let's talk about while loop. So a while loop is slightly different. All it needs inside the bracket here is the checking statement. So in this case here, we could say I is smaller than 11, and then open the squiggly bracket again, it's its own scope. And then we can say while I is smaller than 11, we can go serial.print ln I. Okay, so we have that here. Now, if I run this, it will give me an error. That is, I was not declared in the scope. So for loop is different than a while loop, and actually there's many differences, but one of the major differences that you can see right from the get-go is you need to declare your I statement or your checking statement outside of it. So a while loop is a for loop is used mostly when you want to conceive or you want to keep the I statement inside the for loop. A while loop is used when you're using something else, for example, like a local counter. So when you're using a local counter outside of it, or you're using any variable outside of the for of a loop, and you want to use it in your loop, then that is usually when you would have it in here. Now, in this logic statement here, local counter would not really work to use. So let's keep it as I. What I mean by a logic statement is what you're trying to achieve. It wouldn't make sense to have local counter inside here. So let's just keep it as I. Now this will again give me an error, and I'll show you why in a second here. Now in this case here, it didn't give me a syntax error, okay? But if I try and print this, as you can see here, I never ends, okay? Even though we have a checking statement, it never ends. And that is because we never assigned a value for it, right? It checks if I is smaller than 11, okay? And in this case here, Arduino sets it as a random value. We do not necessarily know what value it is. That's why we always have to make sure it's equal to 0. And what we also need is an incrementation inside the while loop. So we need incrementation in here of I++. Okay. And let's say we didn't have the equal 0 here, just for the sake of showing here. I think it depends on the Arduino version you have. Some version would initialize I as 0, some won't. So in this case here, yes, so the I assigned for here, which we didn't assign ourselves, is seems to be a value bigger than 11. Because as you can see here, it's never printed. High is never printed. Now, just for the sake of seeing this better here, I'm just going to print an empty line by just going CL print. That would just print empty line, so we can visually see the separation between both, and just assign equal to 0 here, and then we can launch the serial monitor, and as you can see, this is what we have. So we have the local counter for a for loop, and then we have the high. It resets because of the void loop. And then it comes back. If we want to add another space, just make it separate from the for loop and the while loop, we can just do that and upload that one here. And as you can see in a second here, it looks how we want it to look. So this is the idea of the for loop, while loop, global variables, local variables, and hopefully that all makes sense. One more thing to talk about, which are quite important, are functions. Now, I do not need these anymore inside the variable here, so we can just talk about a bit more about the functions. But before we do that, I just want to talk a bit more about the various variables we have. So we have float. So int variable is, remember, is integers. Float is just any decimal value. So a float is just a decimal value. It can be global. Remember that variables can be local or global. I'm just putting in global just so you can keep an eye on it. And so I'm just going on here, floats and the decimal. Usually when you print float statements, it rounds it up to 2 decimal places. Now the accuracy of it, you can really, arguably it's about 7 decimal places ish, but you can just you do not necessarily need that big. And even if you do print it, if you do print the float statement, or only print it to 2, if you want to print more, then you do need to add another thing for it, which we will not talk about in this video. But let's say we assign the decimal value here, decimal value here to be equal to 0, even though I had assigned it an integer. Even it was declared as a float, so it will typecast it to a float statement. And just including my comment here, we can just, if we just include this here and print it, we will see that will be a float. But let's talk about the other ones. We also have a long. Long, you will see actually when we talk about the ultrasonic sensor. Long is just a integer statement. It's long used to be called long int, but then it was reduced to long. So even if you type long int, it will still work, but now you can just type long and it will do the same thing. So what this does is the global counter and the integer and the long are both integers, but the long accepts more values. So in other words, it overflows after more amount of numbers. Now, of course, I do not remember the number off the top of my head. So we can just search like for long maximum value. And it depends on which one we're using, but let's take to Arduino. So we can just type Arduino at the end of our sentence here. And as you can see, long variables are 32 bits, which is correct. And it goes from negative this number, a huge number, to this number here. Now, if we look at int, it's a bit smaller and it's a 16-bit value. So as you can see, long is double that. And it only goes from these two numbers here. So this is what we have for long and integer. We can just say long value for it, and then remember to add the comment, which I won't do in that case for the sake of time. So there's int, float, long. There's others you might use, and there is bool. So bool is either a true or false statement. So as you can see, true is a predefined statement here, and false is also a predefined statement. So the idea of a Boolean is only it depends on what language you're using. In Arduino, it's true and false statement are statements of their own. So and bool is short for Boolean, and Boolean. So it is also a variable, but it's not used. You can just use Boolean for it. And it's just, as the name implies, or as I mentioned, it's just a value for true or false. So if I'm assign my Boolean value here, I can just go with Boolean is equal to true, for example. So that is true. That will compile. You in C, which is a very popular language, the Boolean values, there's not really a true Boolean value, but you either use 1 or 0. This also is true. What I mean by that is if you use your if statement for it to work, and if statements, for statements, while loop statements, all of them have a checking statement, right? So for this to work, let's say when I said local or global variable is equal to 5, this evaluates to 1. Okay, if it's true, it evaluates to 1. So if I said if 1, it will always run. If I say if 0, it will never run, which I can show you. So let's say I put all of these actually in if 0. Now there is a slight mistake here, and there is an extra bracket here, I think. Okay, so if I do that, then you won't see that statement here, and which we can check in a bit here. So a 0 will never check. Also, if I do false, it will not work. Okay, so let's start with 0 and we'll see that. Now we can also go serial dot print ln the Boolean value. So Boolean value here, and just to show you, and then so we have int, float, long, bool. In many cases, you might use bool, you might not. It depends on what you're building, but in many cases, int is usually used instead and you can just use 0 and 1 for that. And these will be the most popular ones you will be using. There is quite a few ones that you might not need, whether it's byte, whether unsigned integer. There's quite a few that you might not need. You can also have set integers to be a certain bit long, so 8 bits, stuff, things like that. These are all available, which you can look into further, but for the sake of basics here, you do not need to be aware of it. Now, just to prove that if 0 will not show, if we run this code here and we start our serial communication, and just for the sake of actually seeing it, we can just go serial dot print ln test. This here just show you that the communication, the serial communication is working. Now it seems like I put a colon instead of a semicolon. So I can just upload my code here. And as you can see, nothing shows. If I go false, and shows here in monitor, again, nothing shows. If I actually change this to Boolean value, which remember is assigned to true, it is uploaded, and then we show it. As you can see, you can see that the decimal value here, and then you see your Boolean value, which is, because of serial print here, just change it to 1 or 0. Even though true and false are a proper statement, the serial print just changes it to that. So 0, and if you remember, as I mentioned, the float will as a default only shows us up to 2 decimal places. So we have this one here, and then last one we're going to show is if you have a 1 statement or any integer equal to 1. Then you will have that. And then it runs. So why did I mention this? Because, let's just turn it off. When you're creating your function, if you are returning something, then you need to include what you're returning. So the syntax for writing a function would be a variable type. Then you need the name of the function. And then you want to include, if you need, any parameters. And those are inside brackets. Or you can also call them any arguments. Okay, so this is the formula for it, you could say. And then they do include squiggly brackets as well. They are in the scope of their own. So in this case here, let's have a normal, simple function here, and it returns an int. And let's say we have an int, and we'll call it print name. And then the parameter it needs is string, which I haven't talked about. And let's call the string first name, and another string called last name, and then open the brackets. So as you can see here, we have our int type, our print name, our first name, our last name. So what I'm doing here is, this is as the name of the function, which should imply, is the print name, the first name, and the last name. You should also include a slight comment, whether if you want to include a proper comment here, you can just say the function print name. There is a proper convention to how to write function comments, and I will not go through all of it right now, but you can just say the various parameters, and the first one will be first name, and that would be there'll be no first name of the individual. Last name will be the last name. And then what the function actually does is prints full name through serial communication. And then we can say that requires that serial communication be initialized. Okay, and then we can say here we go serial dot print ln first name, and then we actually want to put in one line, serial dot print space, and then serial dot print, and then make a new line of the last name. And then what we return is a value, let's say 1. So this 1 here, and then we can also include it here, so we can say returns 1 if complete. So you can just use this here and say, for example, we can say if print name, and then we send in the various parameters here. Now, the string function, the string which I haven't talked about, is the only variable that starts with a capital. So the string is actually part of a class, and what it allows you to do, it's a set of characters together, and a string is just pretty much a word. So you can just include a word in it. Now, as you can see here, we send in a word which is Khalid and Al Malawani. A string always has quotations. A character, which also we could talk about, is simplified as car, and is only for letters. So a character is a letter, which can be used if you just want to send in one letter, for example, and characters always have only one quotation mark. So we can say letter is equal to K. Right? So that's character. If we go serial dot print, and then if we go serial dot print ln and we press the letter, we would just print the letter as it is. And as you can see here, we only have one quotation. Okay, so this is what we have here. So we have the if print name Khalid Al Malawani. This will give me an error, and I'll show you why in a second. Then we can say serial dot print ln. I want to keep a space and go serial dot print ln complete. Okay, so this is what we have so far. Now, if I do upload this and it will save and then compose, it will give me an error, and it says here it's missing a bracket. That is because if you actually press near the bracket, it tells you which bracket it's closing. There's no bracket for the first one here because I forgot to add another bracket here. If I compile and upload the sketch here, we will see the first name was not declared in the scope. That is, as you can see, we in coding or in any language, the name of the variable has to be the exact same, right? So you have to make sure that these are the exact same. A way to avoid this is to always copy or paste and paste. So that's what we do here. And then you can launch this code here. And then we can open the serial monitor. And as we can see, it does it for you. So it prints name, and then it prints complete, and then it repeats for the void loop. Okay, last statement to talk about is the break. The break statement is any statement you can include, is a statement you can include only in loops, whether it's the void loop, it's the while loop, or the for loop. So this is to break out of loops, right? So in other words, if you build a loop that doesn't have a definite, especially in while loops, if you don't build a loop that doesn't have a definite ending, let's say you declare a loop that's while run, for example, so it always runs, and then you have something and you say if I don't know, if Boolean value, for example, if Boolean value is equal to true, then we can say break. I will break out of the loop. Even though it's inside the scope of the if, the break always looks for what is the nearest loop and then breaks out of it. Okay? So if let's say you have nested loops, if you have nested loops, we need another one here. And we can go Control A, Control T, or go sketch tools auto format. Control T will just make it look neater. What this will do is it will break out the first one, but will not break out of the second one. Okay, now this one here I do not need because it is an infinite loop. It is not necessary. What this break does is it will break out the void loop. And if I compile the sketch here, so the break statement on the new update for the Arduino does not work for the void loop, right? So it only has to be inside a while or a for loop, which is important to note because a lot of people think that it will break out the void loop. You cannot really break out the void loop, but you can create a while loop that looks like it stops. So break out of loops while or for. Okay. So a way, if you want this to stop, what you can do is just create a while one loop, which actually, for the sake of this here, you can just uncomment this. So what this will do is it will stay here. It will stay inside the while loop, and because it's an infinite loop, it looks, if you look at the serial command, the serial monitor here, and just oppose it, make sure there's no errors, and we launch this, it looks like it completed. What's it actually doing? It's stuck inside the while one loop. It broke out of the first one, and it's stuck inside the higher up while loop, and so it never runs again. It just looks like it's complete. So that is one way to make it look like it's stopped, and it is quite useful. So this is an approach that you could take. A lot of people who program Arduino do take it. And then you can also include a statement to break out of it. It's quite simple. So that walks a bit of how to use to better use the for loop and the while loop, especially. That's why while loops are actually quite important. And that walks you how to use functions and the various variables. So that should be enough to get you going inside for the Arduino development. Now, this is good for the basics, but something you should always know is that a good coder is not necessarily is not a coder who can necessarily memorize everything. A good coder is somebody who can actually has good researching skills. So what I mean by that, actually, for the sake of practice here, let's just do another version of this one and go Arduino Basics tutorial version 2. And then, so in this case here, we know that this code works completely. We don't want to play with it. Or at least if we want to go back, we know it works. If you need anything, Arduino, the cool thing about Arduino is especially the Arduino forum, is huge. A lot of people have been coding Arduino for years. So a lot of things you will search here will work. But let's say, which we will talk in next videos here, but let's say you want to get going here and you want to see how the ultrasonic sensor works in the Arduino. You can just type ultrasonic sensor Arduino. You will see a lot of website that helps you. The popular one is the Create Arduino website. There's also Instructables, How to Mechatronics. All of these are pretty good tutorials. You can just select any one you want. And then it will pretty much walk through what you need. This is his project here. he is using the simple ultrasonic sensor using Arduino Uno. Usually anything you see online that works with the Arduino Uno does work with the Arduino Mega. The Arduino Mega just allows you to do more because it has more space. It talks to you about comms and tools, which you should be aware of. And then it just goes through a bit here. Now, it usually includes the code. This is what I'm looking for. So in this case here, we can just copy the code. With the button here, you just go, you can go inside here and press Control, select and print it. And then we can go back to our Arduino code here and either create a new file, or if you want to include it here, you can just include it here. Now, just for the sake of practice here, or just so you can see, you cannot have two setup and loop functions in one code. So if I start compiling this, it would say redefinition of void setup, which makes sense. It's the same case for any function. You cannot have the same two functions with the same name. So we can just take this one here and copy it and put it up here. Now, what I will talk more about these here in just a second. But for the actual use of the ultrasonic sensor, there will be another video about it. So we can just ignore these here and just remove them. I want to put this here and do this one like this. Now, remember, we talked about all the different variables, but one thing we didn't talk about is the definitions. So that definitions are quite useful. So you can create global variables or just declare definitions. So in this case here, we are declaring definitions. So what this does is instead of having a let's say an int for the echo pin, what I'm doing is I'm defining the echo pin. So what this means, it's pretty much similar to a constant int. So a constant int or a constant anything, basically, if you add constant before any of these variables, that means you can never change it. If you do change it in your code, so if you do, let's say, increment global counter, for example, and you have a const, when you declare it, it will give you an error. It will say that it's constant, right? Which we can test in a second here. But the idea of constant int is you can change it, right? So yeah, the hashtag define, the only difference between this and the hashtag define is the hashtag define does not take any space from your memory, so from your flash, because how the compiler reads it is it keeps it as an empty space. That's where they are declared here or here, and then after that it adds whatever value you put right beside it in here. Now notice that the hashtag define does not have any semicolon. That's the only time you don't have a semicolon beside your any statement in the Arduino. So when you have the hashtag define, it's only one line. You have the name, the declaring definition. The formula for it is, of course, you include hashtag define first, hashtag define, and then you have the name, and then you have a value. Okay. If you include brackets in your value, it will include brackets in here, which will result in an error. Right, so make sure you don't include brackets. It's a common mistake because what the hashtag define does, anything you have after the name prints it exactly as it is. So if you have bracket space 2, it will. You should avoid spaces in these because in many cases it won't work. But it will print this exactly as it is. Right, so you should try and avoid this and just keep the value you want right ahead. So you have this here, and then you can just use it. Now, proper convention for this actually is to declare them all in caps. And if you have more than one word, you can put underscore. That's the proper convention for it. And then we can just use them down here, and it will work. And that's a bit about these. Now, last thing we're going to talk about here is the pin modes. So pin modes are quite important. This code here we do not need for now. So the pin mode here, there is every Arduino board, especially the Mega and the Uno, have an LED built in. It is defined by this statement here, LED built-in. So what you put in your first statement of the pin mode is the pin. In your mega here, you have up to 53 pins, 15 analog pins. So 53 digital pins and 15 analog pins. Or you start with 0, so technically it's 54 and 16. In your Uno, you have a bit less than that. But what you include in your pin mode here is actually what you want, right? So it's either the pin number, in this case, the LED bulb built in the Arduino Mega and the Arduino Uno. If I remember correctly, it was the same pin as pin 13. So if you have LED built in 13, if you have 13 here, it will also be the same. But let's keep it this way so you can hear it better. And then you want to specify, is it output or input? As the name implies, if it's output, you're going to output something to it. If it's input, that means you read from it, right? So in this case here, we want to declare it as output. And then to write something to it, we can just go here and go digital, right? So a digital just means it's either 0 or 1, okay? There's analog write and there's analog read, which means you can read more than 0 or 1, which we will talk about later. This is important for the various sensors, and we are not talking about sensors yet. So digital write here is 0 or 1, and then we can go digital write, and then you include the pin number again. And then you include high or low. High or low based on high just means turns it on for an LED, and low just means turns it off. So this is the two things you'll need here. There's also digital read, as I just mentioned, and in this case here you just include the name of the pin. But if you do use digital read, you should include this as an input. You are allowed to read, even though you declared the LED built in as an output, you are allowed to read it. So if you do digital read, it will work, but it's not proper. You should not do that because it depends on your sensor. For LED, it won't, but in many sensors, it will break it. So if you declare it as output, make sure you're only outputting to it. So in other words, if you declare it as output, you can only use digital write. If you declare it as input, you can only use digital read. Okay, so that is what we have here. Now, if you look at the LED here, so the LED on my robot here will be right here. So it will be orange. Now the LED is built in, so that means when you upload any code, it flashes for a bit. So once again, it's right above the red and blue marks right here, red, yellow, and black marks here. Okay, so if I just see my computer for a sec and upload the code, it flashes for a bit. When it starts uploading, there is an error in my code currently. And that is, yep. So remember how I specified that if you have a constant int, you cannot change it. So this is exactly what I wanted to show you. So if you if you declare a constant beside any variable and you try and change it, you try to assign anything to it, it won't work. If you do want to assign to it something at the very beginning, you can put it like this: constant int global equal to 0. That is the only time where it is acceptable to assign your variable at the very beginning as part of the convention purposes. And that means this should work now. And if we go here, there is another error here. Oh yeah, so in this case here, I'll just, actually I don't need these at all because we will talk about the ultrasonic sensor in a later video. So I just upload this code here. And as you can see, it just turned on. So the first flashing at the beginning was just uploading. Now, just to make sure that it works, we can just change the code here and make it low. And then if we upload the code here, so it's the LED right here. And as you can see, it turned on. So that shows that the digital write and digital write works, and as well as the pin mode works. So when you have different pin modes, you need to have that, and you have to make sure that you're able to read them. Even if it's analog, you need to include them. Now, analog pins start with an A, so you can either have an A1, and it can either be an output and input as well. It's just that when you read them, it will be different. Instead of analog write or read, sorry, instead of digital write or read, you will have analog write or analog read, and that is the only difference. So that walks through everything you might need for the basics. And yeah, so see you on the next video if you're going to watch it. If not, then good luck on your Arduino endeavors and best of luck.